let's try to prove these new formulas. And so that's what I was saying, write this out as sine of theta plus theta, because then that is your alpha and beta, right? So now you're going to be plugging it into the sine alpha plus beta formula. So if you do that, the formula is sine alpha, so that's sine theta, cos beta, which is theta, plus cos alpha, which is theta, sine beta, which is theta. But when you multiply these things together, do you understand that these two are actually exactly the same? Yeah. So then, can you add them together? Yeah, so you get two of them. 2 sine theta, cos theta. So that is your first formula that we're going to be, they're using alphas. So we're going to use 2 sine alpha cos alpha. Okay, let's prove sine 2 theta now. Cos 2 theta. So same thing, rewrite this as theta plus theta, so that this is your alpha and this is your beta, and put it into the cos alpha plus beta formula. And I'll give you a second to do that. So if you put this in, you get cos theta, or alpha, cos beta, which is theta, subtract sine alpha, which is theta, and sine beta, which is theta. So if I multiply cos times cos, what do I get? Cos squared theta and sine squared theta. So we have a formula for cos 2 theta to be cos squared theta minus sine squared theta. Now you notice that I have three spots for this. Why is that? To drive you crazy. So remember sine squared plus cos squared equals 1? I can actually replace this and get two different formulas. So if I replace cos squared theta with 1 minus sine squared theta, and then I still have the minus sine squared theta, do you see I'm getting 1 minus 2 sine squared theta as a new formula? And if I replace sine squared theta, so I'm going to write cos squared theta, subtract bracket. I'm going to replace sine squared theta with 1 minus cos squared theta. So that, watch the bracket here with the minus. So we get cos squared theta minus 1 plus cos squared theta, which means it's 2 cos squared theta minus 1. So that's my other formulas I'm going to add into there. So 1 minus 2 sine squared, I guess it's alpha, and 2 cos squared alpha minus 1. So you might say, well, how do you know which one to choose? It doesn't really matter. In a proof, if you choose the wrong one, you'll probably get to a dead end or go a long way if you choose the wrong one. Sometimes it's very obvious which one you'll choose because, for instance, the right-hand side only has signs in it, so then you should be choosing the one only with sign in it, right? Things like that. Okay, yes? Oh, shoot. I should change this, because that would be what? Introducing a variable. Thank you for correcting my theta there. Yes. Okay, do you guys want to prove tan now? Okay, don't you feel good about you can do these things now? Yeah? Okay, so tan alpha or theta plus tan beta, right? Minus 1 minus tan alpha tan beta. So if I add tan theta and tan theta, I get 2 tan theta. And if I multiply tan theta times tan theta, I get tan squared theta. So I will write that up there with alphas though. So 2 tan alpha over 1 minus tan squared alpha. Does everybody see this on their yellow formula sheet?
Sure.
Yes? Okay. So, example 2. If sine theta is 3 over 5 and theta is between 0 and pi over 2, do you recognize this type of question? What is it? The triangle. So what, I thought I lost it. What quadrant should I draw my triangle in? The first quadrant, yes. And I'm going to do theta because they're using theta. And what else do I know about my triangle? Opposite is 3, hypotenuse is 5, and I automatically put a 4 in there because I know it's a 3, 4, 5 triangle. Yes? Okay, so now, how am I going to find what sine of 2 theta is? Hey, it's a formula on your formula sheet, which is equal to 2 sine theta cos theta, which means I need to know what sine theta is and cos theta is. I don't know what cos theta is, but I do know that sine theta is 3 over 5. I want to make sure everything's good. So 2 times 3 over 5, and what's cos theta equal to in this triangle? 4 over 5, positive or negative? Okay, I'm going to give you a second to multiply this together without a calculator and see what you get. So if you want, you can put a 1 in there just so you know that you're only multiplying the bottoms and the tops together, so you get 24 over 25. Okay, so for fun, because I know math is so fun. Am I recording this? Yes. Okay, this side of the rune is going to take the first formula of cos 2 theta. The middle is going to take the second formula. And this side is going to take the third formula. We're going to see if we're going to get the same answer, which we should because, okay, so you guys, everybody got 7 over 25. So I'm going to do cos squared theta minus sine squared theta. So this is 4 over 5 squared minus 3 over 5 squared. 16 over 25 minus 9 over 25. So there's number 1. Number 2 is 1 minus 2 sine squared theta, right? So that's 1 minus 2, 3 over 5 squared. You got to use order of operations, so you got to square the fraction first. So that would be 9 over 25. So that's 1 minus 18 over 25. Do you see you'll get 7 over 25 as well? Oh, I didn't put the answer up here. 7 over 25. Do you want me to do the third one? So that is 2 cos squared theta minus 1. So 2 times 4 over 5 squared minus 1 is 2 times 16 over 25. Subtract 1, which is 32 over 25. Subtract 1. 1, of course, is 25 over 25 when you have that fraction, right? So that gives you 7 over 25 as well. So again, it doesn't matter which one you pick. You don't have to pick all 3. Just, I wanted to prove to you guys that it doesn't matter, right? Just pick one, whatever you're comfortable with, and do it. So let's do tan of 2 theta. Yes? So that is 2 tan theta over 1 minus tan squared theta. So we need to figure out what tan theta is, right? So what's tan theta equal to? 3 over 4. Everybody agree? Yes? So this is going to be 2 times 3 over 4 over 1 minus 3 over 4, the whole thing squared. And I'll give you a minute to figure that out. Again, this is without a calculator. Okay, so on top I get, well, I would maybe cancel the 2 and the 4 and get 3 over 2. And then 1 minus 9 over 16. So this is 3 over 2 divided by, well, 16 over 16, subtract 9 over 16 is 7 over 16. And then the 2 goes into the 16 8 times, so then I get 24 over 7. Okay. Are you guys doing that technique now for division? Are you confident enough to do that? That's good. We're expanding our horizons here. Okay, so I'm going to cheat and just write it like this, so I don't have to write it again. Okay, so most people I saw change tan to sine over cos. So I'm going to do the same thing. 2 sine theta over cos theta over 1 plus sine squared theta over cos squared theta. Some people are having trouble with the 2. They didn't realize it's 2 over 1. I don't know why they thought it was 2 over 2. That would have been 1 then, right? So anyways, I need to get a common denominator here. So 2 sine theta over cos theta divided by, and then 1 becomes cos squared theta plus sine squared theta over cos squared theta, yes? And then you should be recognizing that this is 1. So 2 sine theta over cos theta divided by 1 over cos squared theta. And do you understand that when you flip and multiply, the cos thetas will cancel? So one of these cos thetas will cancel one of those cos thetas. And where does that cos theta end up? On the top. So you get 2 sine theta cos theta. At this point, you can either rewrite it as sine 2 theta or write the right side as that. So it's up to you if you want to do that. I think a lot of people did this. 2 sine theta cos theta. Therefore, the left-hand side equals the right-hand side. Okay, try the next one. Do the same thing here. Okay, so hopefully you got a chance to try this. So it looks like cos is on the right side, so I'm going to turn my tans to sine over cos. So 1 minus sine squared x over cos squared x over 1 plus sine squared x over cos squared x. I see a lot of people writing it as cos squared over cos squared. See if you can get to the part where you can actually just go as cos squared x minus sine squared x all over cos squared x. You don't need that intermediate step, cos over cos. You guys are better than that. Okay, so then the next step is cos squared x plus sine squared x over cos squared x. I caution you on canceling too many things at once. You need to do one step at a time. Remember, proofs are about showing you steps. So if I cancel the coses, then rewrite it. So cos squared x minus sine squared x divided by cos squared x plus sine squared x. And then you recognize that this is 1. So cos squared x minus sine squared x divided by 1. So that is just cos squared x minus sine squared x. So if you want, you can change that into cos 2x, or you could go up here and pick that formula. Cos squared x minus sine squared x. Therefore, the left-hand side equals the right-hand side. You could have changed that to that over there, right?